Hi, this is an overview of the proposed design for our project, Plagiarism Detection Tool. It's been designed for the System Practicum course at IIT Mandi. Project summary. With an increased access to the internet nowadays, there's been a lot of copying of source code files, mainly by students for their projects and assignments. So our objective is to use concepts of OS and networking like threads, system calls, processes, etc. in building a plagiarism tool to detect plagiarism of source code files. This is implemented to detect copy-paste plagiarism as well as disguised plagiarism. The tool is optimized to work with average computational power also. Another objective is to improve the speed and robustness of our tool.
Detecting copied files. The folder with files to be checked is given as argument to our function or tool. We use a combination of various algorithms with some weights assigned to them to generate a similarity matrix as output in a file. And these values are based on how much similar they are to each other. So this output can be used for further inference and statistics based on some user-given threshold.
Algorithms used. Morse algorithm. In this algorithm, all the white spaces and punctuation for each source code file are converted to characters in lowercase. We then divide the remaining non-white space characters for each file into kgrams, which are contiguous substrings of length k. We do this by sliding a window of size k through the file. In this way, the second character of the first kgram is the first character of the second kgram, and so on. Then we hash each kgram and select a subset of all the kgrams to be fingerprints of the document. The fingerprint includes information about position of each selected kgram in the document. We then compare the file fingerprints to find similar files. Now we have the token algorithm. In this algorithm, we firstly remove the comments, identifier names, and white spaces. We then replace the code statements with a sequence of tokens. Then we compare the token sequences to find similar files.
To overcome these problems, we have the hybrid approach in which we combine different algorithms, and the similarity score is a weighted sum in which the weights are optimized by experimenting with different values.
The basic level is the metric algorithm. It's a simple algorithm that checks for similarity of source code for copy-paste plagiarism. In this one, we check for the total number of loops and conditionals. If the score obtained from this algorithm is above a particular threshold, we continue to the next level of plagiarism detection. Otherwise, we can be sure that the files are miscopied, and hence the detection is stopped at this level. If the file in consideration is a text document, this step is skipped and we move on to the next level of detection.
The second type of algorithm we have is the string matching. In this algorithm, we take sets of n consecutive strings and match them for similarity. The score is assigned based on number of word matches, and this is then added to the total similarity score with some weightage. If the score is very high, the files are classified as copies. The third level of detection is fragment matching. This is particularly useful when the order of the segments of source code is altered. Here, we take fragments of code and then compare it with every other fragment of the other file. Fragments can be lines or sets of strings or even sets of lines. The next and final level of detection is token matching. This is similar to the Morse algorithm which we have discussed before. But when this is applied after the previous levels, it makes the overall detection much faster and efficient, especially for large number of source code files and batch processing. Given the advantages of our algorithm, there are some limitations also. The first problem is when assignments are very basic and specific. In this case, there is no way to detect plagiarism because the source codes are almost the same for everyone. Since we do not use high-end machines, there may be limitations on the time and computation involved. The project is expected to last around 4 to 5 weeks depending on features included. And depending on the time constraints, other features like most copied code segment and graphs may be included.